Okay, so when we talk about high voltage grid protection, what's the one thing we all want to avoid? Unplanned downtime. It's the ultimate enemy. But what if I told you that the very solutions you're counting on to prevent it might actually be setting you up for failure? We're going to dig into a hidden flaw in how we usually handle grid insulation, and it's a big one.
So tell me if this sounds familiar. You've gone out, you've installed all the right insulation sleeves and line covers, and you think, okay, that circuit is secure. And then a fault happens anyway. It's incredibly frustrating, right? And it points to a much deeper issue than just which brand of cover you picked. You see these things everywhere, don't you? Conductor covers, insulation sleeves, tapes, and look, they are absolutely essential pieces of the puzzle. But, and this is a big but, just installing them doesn't mean you have a total solution. In fact, that kind of thinking can create a really dangerous false sense of security. All right, so let's start on common ground. For pretty much every utility engineer out there, the big goal, the holy grail, is zero unplanned downtime. Reliability is absolutely everything. And what's the go-to strategy for this? Well, it's pretty straightforward. Protect your energized hardware. The logic makes perfect sense, right? You add a dielectric barrier, you prevent contact, and boom, you prevent faults. It is the standard playbook for hardening a distribution line. But here's where we get to the real heart of the issue. The source material we're looking at calls this the insulation illusion. It's this belief that just slapping a cover on a conductor is the end of the story, and that can be a really dangerous assumption to make. Because the reality, what's actually happening out there on the lines, is that flashovers are still a problem. You have facilities that have been so diligent about installing insulation, and they're still seeing outages. It leaves engineers just scratching their heads. So the million-dollar question is, what are we missing here? Well, the answer isn't in a product catalog. It's in the physics. To really get why these systems fail, we have to stop looking at just the sleeve and start looking at how electrical stress is distributed across the entire setup. And that brings us to this key concept, the stepped insulation profile. Just picture it. You've got this highly insulated cable, right? And then it suddenly ends and meets a piece of uninsulated hardware like a clamp or a bushing. That sharp drop-off, that cliff edge in the insulation level, that's the step. Now here's where the trouble starts. In high-voltage systems, that sharp step isn't just a simple transition. Oh no. It acts like a magnifying glass for electrical energy, concentrating a massive amount of stress right on that tiny little edge of the insulation sleeve. And this concentration kicks off a devastating chain reaction. First, all that stress builds up right on the edge. Second, that intense pressure starts to break down the air around it, or it begins crawling along the surface. That's what we call corona discharge or surface tracking. And finally, that tiny breakdown just cascades into a full-blown flashover, and your grid goes dark. So, we get the physics of the step, but that's not all. It gets even worse when you factor in the real world. A lot of those generic, universal covers you see, well, they just aren't engineered to handle the specific environmental beatdown they're going to face out there. The source points out three major culprits. First up, surface tracking. You get a little pollution, a little moisture, and bam, you've created a tiny highway for electricity to travel where it shouldn't. Second, thermal cycling. You know, things heat up, they cool down, the cover and the conductor expand and contract, but at different rates. This creates tiny microgaps perfect for moisture to sneak in. And third, geoelectric mismatch. A poor, sloppy fit leaves air gaps. And since air is a terrible insulator at high voltage, it can ionize and start eating away at the sleeve from the inside out. So if the problem is this total lack of coordination between the sleeve, the hardware, and the environment, then the solution has to be a truly coordinated system. This isn't about finding a better sleeve. It's about designing a smarter system from the ground up. I love this because it connects all the dots so perfectly. You want to fight surface tracking? You need advanced material chemistry. Things like high-grade silicone that's literally designed to resist it. You want to solve that step effect in a bad fit? You need thoughtful interface engineering. And to beat thermal cycling, you need a material with incredible environmental stability, one that has the elasticity and memory to stay snug, no matter how hot or cold it gets. And this brings us to what I think is the biggest, most important takeaway here. We have to fundamentally shift our perspective. It's not just about installing a cover, it's about engineering a complete solution.
This quote from the source material just says it all, doesn't it? A sleeve is a precision component, not a generic accessory. You would never treat a high-voltage transformer like some generic off-the-shelf part, and we have to apply that exact same thinking to our insulation. It's a critical precision component. So the next time you see a reoccurring fault on a line you thought was protected, the question shouldn't be, is this a bad sleeve? The real question, the better question, should be, is our entire insulation system truly coordinated for the electrical and environmental stresses it's actually facing? Now that is the right diagnostic to run. And that really leaves us with this one final thought to take back to your own operations. Are you treating your insulation like a simple, interchangeable commodity you can just buy off the shelf, or are you designing and implementing it as a coordinated, engineered system? Because the answer to that question could very well be the difference between grid reliability and your next unplanned outage.